Let's continue with task statement 2.1 and talk about generative tasks and use cases. Large language models, LLMs, are a type of generative AI that can be applied to many different problem domains or tasks without being fine-tuned. What are the main use cases for generative AI models? First, generative AI generates text and might be useful for writing or rewriting pieces of text to adapt to different audiences. For example, you could adapt or convert a technical document that is written about the design and specifications for a scuba diving buoyancy device. To be more specific, you could have it use less technical terms for people who are beginning their scuba diving certifications. Generative AI is also good at text summarization. You can give it a relatively long piece of information and have it generate a short output while retaining the main idea. Examples could include summarizing technical documentation, financial reports, legal documents, news articles, and more. AWS provides a range of services and tools for building generative AI applications for content creation. For example, Amazon Bedrock and Amazon Titan offer pre-trained models for text, image, audio generation that could be fine-tuned for specific use cases. SageMaker and Amazon Q Developer, formerly known as Amazon Code Whisperer, support code generation and completion. Amazon Nimble Studio and Amazon Sumerian offer virtual production and 3D content creation. There are more examples of other use cases, such as information extraction, question answering, classification, identifying harmful content, translation, recommendation engines, personalized marketing and ads, chatbots, customer service agents, and search. Another use case is the use of generative AI as a developer tool for source code generation. Code generation is an application of generative AI to accelerate software development. Models can generate functional code snippets and even entire programs from natural language descriptions or examples to help automate routine programming tasks, suggest code completions, and even translate code between different languages. Amazon Q Developer generates real-time code suggestions that range from snippets to full functions based on your comments and existing code. AWS handles the underlying infrastructure, data management, model training, and inference. You can focus on your specific use cases and applications. For the exam, ensure that you understand that various architectures exist, such as generative adversarial networks, GANs, variational autoencoders, VAEs, and transformers. Each architecture has unique advantages and limitations. So, evaluate the objective and dataset before selecting the appropriate one. I'm going to pause this lesson here, and in the next lesson, we will continue with task statement 2.1. Let's wrap up this task statement and walk through a generative AI project lifecycle. This framework maps out the tasks required to take your project from conception to launch. The stages are: identify a use case, experiment and select, adapt, align and augment, evaluate, deploy and iterate, and monitor. The first stage of the AI cycle is to define objectives, collect data, process data, select your model, and train and develop your model. The next stage is to develop your model by using feature engineering, building, testing, validating, optimizing, and scaling. Last is the stage to deploy and maintain, which includes model evaluation, deployment, feedback, updates, security, and scalability. The exam guide lists the foundation model lifecycle as data selection, model selection, pre-training, fine-tuning, evaluation, deployment, and feedback. The most important step in any project is to define the scope as accurately and narrowly as you can. You should think about what function the LLM will have in your specific application. Do you need the model to be able to carry out many different tasks, including long-form text generation? Or is the task much more specific, like named entity recognition, so that your model only needs to be good at one thing? Getting specific about what you need your model to do, you can save time and, perhaps more importantly, compute costs. As soon as you're happy and you have scoped your model requirements enough to begin development, you're ready to get started. Your first decision will be whether to train your own model from scratch or work with an existing base model. The next step is to assess the model's performance and complete any additional training if needed for your application. Prompt engineering can sometimes be good to get your model to perform well. Therefore, you'll likely start by trying in-context learning using examples suited to your task and your use case. In some cases, however, the model might not perform as well as you need, even with one or few shot inferences. In that case, you can try fine-tuning your model. This process is a supervised learning process. As models become more capable, it's becoming increasingly important to ensure that they behave well in a way that aligns with human preferences in deployment. So, include an additional fine-tuning technique called reinforcement learning from human feedback, which can help make sure that your model behaves well. An important aspect of all of these techniques is evaluation. Also, try different metrics and benchmarks that can determine how well your model is performing and how well it aligns with your preferences. This stage of development with adapting and aligning is usually highly iterative. I prefer to start by trying prompt engineering and evaluating the outputs, and then using fine-tuning to improve performance. And of course, always revisit and evaluate the prompt engineering to get the performance that you need. Finally, when you've got a model that is meeting your performance needs and is well aligned, you can deploy it. Your model can be deployed to your infrastructure and integrated with your application. Ensure that you are optimizing your model for deployment and your compute resources too, and that the application provides a great experience to users. The last but very important step is to consider any additional infrastructure that your application will require to work. Remember that some fundamental limitations of LLMs can be difficult to overcome through training alone. These issues might include hallucinations, inventing information when the answer is unknown, and the limited ability with complex reasoning and mathematics. Okay, let's continue with task statement 2.2 in the next lesson.